Hello out there to everybody, and welcome to this our YouTube channel. In today's video we shall be looking at how we can answer this differential equation that is being displayed on screen. Now we have e raised to the power dy by dx plus y on x, which is the same like x minus 1 all that raised to the power 2024. So guys, as you can see here, it's an easy trick. Yes, it's an easy trick. The fate of you solving this problem depends on your first step. Yeah, it does depend on your first step. So guys, please, just for a quick reminder, please, if you're new to our channel, I highly encourage you to please subscribe to the channel and press the notification icon so that each time we upload videos, guys, you will be the first person to be notified. And please give this video a like. Just please press the like button just beneath this video so that it is going to motivate me to produce more great content for you. Thank you very much for subscribing. Thank you for liking, and please don't forget to share this video out with your friends, because that way it is going to help so many people to be able to locate our contents, and they are going to watch. Thank you very much. And guys, please, this question was proposed to me by one of my subscribers. She sent the question to me via email and she wants me to make a video on how to solve it. Okay, now let's dive straight into the solution right now. Okay guys, this is the question we have here. All right, now let's see if we can solve the problem. Now guys, as I'm saying, I have e raised to the power dy by dx plus y over x, which is the same like x minus 1 all that raised to the power 2024. It will be so good if I can bring this dy by dx down, because to solve the differential equation, it will be so easy if I have my dy by dx as a base, not as a power. Great. So guys, the first step I'm going to take here is by taking natural logarithms on both sides. So I'm going to have, if I take natural log on both sides, I'm now going to have the natural log of e raised to the power dy by dx plus y over x, which is the same like the natural log of x minus 1 all that raised to the power 2024. That's great. So guys, and we know that the natural logarithms and the e are two functions, are two inverse functions, right? That therefore means that the natural log of e is simply going to be 1. So what we have here in the power simply comes down. So we're now going to have dy by dx plus y over x, which is the same as, and we know that the log property tells us that we can shift 2024 and send it to the left hand side, right? So by so doing, we are going to have our 2024 this way. Then we have the natural log of x minus 1. Good. So now guys, in this case, now we see that we could solve this problem by using a suitable integrating factor, since our variable separable will not do us any good, because if we try to separate the variables by putting all the x, all the terms containing x and dx on one side and all the terms containing y and dy on the other side, is not going to work so well. So in this case now, all we have to do is use a suitable integrating factor. Good. So we are going to have our if, which stands for integrating factor, which is the same like e raised to the power of the integral of the coefficient of y. Since we are dealing with dy by dx, it is going to be the coefficient of y, and in this case it is what, 1 over x dx. And guys, keep in mind that the integral of 1 over x dx is simply going to be what, the natural log of x. So we have the integrating factor if to be equal to e raised to the power ln of x, and we know that e and the ln, they can cancel, right? So we simply have x as our result. Good. So this is our integrating factor x. Now guys, the next thing now to do is to multiply this entire de, this our entire differential equation now, by x, which is the integrating factor. So by so doing now, we are simply going to have x dy by dx plus, now x will cancel with this other x, and we have y, which is the same like multiplying here by x, we have 2024 x times the natural log of x minus 1. Cool. So now guys, we see that by multiplying now by the integrating factor, we now recognize that the left hand side of this our de is now exact. Exact simply means that we could express the left hand side as the derivative of two functions. Namely, we can express the left hand side as the derivative with respect to x of xy. Now let's try to verify if our guess is true. Now let's keep x constant and differentiate y. We are simply going to have x dy by dx, which is what we have here, plus now differentiating x and keeping y constant. Keep in mind, guys, that we have to differentiate with respect to x. So now differentiating x with respect to x simply gives us 1. Then differentiating y with respect to x gives us what? Gives us dy by dx, which is what we have here. So guys, now we see that we could express the left hand side as what? The derivative of what? The product of two functions, namely x, y, which is the same like the right hand side stays the same, 2024 x times the natural log of x minus 1. Good. In this case now, we are going to multiply all through by dx, and we integrate both sides. We are now going to have now the integral of the derivative of xy, which is the same like the integral of 2024 x times the natural log of x minus 1. Good. So now in this case now, we are going to take out this 2024 outside of the integral. Since it is a mere constant, we can take it outside of the integral and try to integrate x times the natural log of x minus 1. Now guys, let's observe, let's see if we can evaluate this integral on a separate page. So guys, we are going to do that using integration by part, and we are going to use the DI method. Keep in mind, guys, that the DI method is a summary of the integration by part method. Great. So we are going to write our D this way, and we are going to write our I this way. Secondly, now guys, we are going to bring forth the signs that they are supposed to get. We start first with what? The plus sign, and we go to the negative sign. Good. So now the signs alternate between what? Positive and negative. So this is going to be plus, and this is going to be minus. If we need more rows, we are going to write plus and minus, and so on and so forth. Now guys, now this D stands for differentiation, I stands for integration. So we are going to come to this our function x times natural log of x minus 1, and we are going to choose which part to integrate and which part to differentiate. So guys, what do you think? What do you think? So in this case now, we are going to differentiate the natural log of x minus 1 and integrate x. Why am I doing so? I am doing so because if we want to integrate natural log of x minus 1 and differentiate x, we will see that to integrate the natural log of x minus 1, we still have to use the integration by part method just to do that, and it's going to be so cumbersome, right? So in this case now, since we can differentiate the natural log of x minus 1 conveniently, and we can also integrate x conveniently, so it will be so good for us to differentiate the natural log of x minus 1 and integrate x. Great. So we'll differentiate the natural log of x minus 1 and we'll integrate x. Good, guys. To differentiate now the natural log of x minus 1, we are simply going to have the denominator down and the derivative of the function up. So we are going to have our x minus 1 down, which is the function part inside of it. Then now the derivative of x minus 1, which simply gives us 1. That's what we have. Then guys, integrating x simply gives us what? 1/2 x squared. That's great. So now guys, this now translates into the integral of x times natural log of x minus 1, which is the same as, now in this case guys, we are going to multiply the diagonals here to give us the first part of the answer. Then we multiply now this row and still put it inside of the integral. So we are going to have like I said, we'll multiply these two we are going to multiply these diagonals as we have here. Namely, we are going to have 1/2 x squared into the natural log of x minus 1. Then now we multiply these two guys and still put them inside of the integral. So we're now going to have minus 1/2 times the integral of x squared all that on x minus 1 dx. Great. So now guys, if we do that now, we are simply going to have this part itself, which is here. Then now to integrate this guy, now we see that the numerator has a greater power than the denominator, right? Namely, the degree of x in the numerator is is twice the degree of x in the denominator. So in this case now, we have to somehow try to reduce it, because guys, each time you are being asked to integrate a fraction, all you have to do is a fraction that contains a variable, all you have to do is try to verify if the derivative of the bottom will give you the top. In this case, it will not give us. The top is rather heavier than the bottom. So in this case now, it will be so good for us to make things happen. Great. So in this case now, we are going to subtract 1 from the power and add 1. Guys, what do you notice? That we have simply added 0. Why zeros? Negative 1 plus 1 gives us what? 0. We are still going to have x squared all over x minus 1, which is exactly what we have here. So now, by that now, you're not going to be asking me where the negative 1 came from, because we've just added 0, and adding 0 simply leaves the function unchanged. Okay, now guys, what can we do with x minus 1? We see that we could express x minus 1 as what? The difference of two squares, namely x minus 1 into x plus 1. But keep in mind that we have x minus 1 on the bottom right, so it will cancel with one of the guys that we have up. So by that now, we are simply going to have this guy, we leave it unchanged, minus now 1/2 times the integral of x minus 1 up has cancelled with the 1 down. They will simply have 1 here, all that on x minus 1. Good. So now guys, in this case now, we are going to integrate term wise, and keep in mind that the integral of 1 over x minus 1 dx is simply going to be the natural log of x minus 1 times all over the derivative of what we have here. So now integrating, guys, we are simply going to have this guy stays unchanged. Then they were going to keep the 1/2 outside. Then now the integral of x minus 1 simply gives us what? 1/2 x squared. Then the integral of 1 gives us x, plus now the integral of 1 over x minus 1 gives us the natural log of x minus 1 plus our constant c in this case. Okay, now guys, if we proceed now, we are going to, if we start by multiplying all through by 2024. Why are we doing so, guys? We are doing so because under normal circumstance, from this our step, right, we were to integrate 2024 x natural log of x minus 1. We brought this guy outside. Now we have integrated this whole guy to have what? To have 1/2 x squared natural log of x minus 1 minus 1/2 into 1/2 x squared plus x plus natural log of x minus 1 plus c. So now we have to multiply everybody here by what? 2024. Good. So multiplying everybody here, guys, it gives us 1, because 2024 divided by 2 simply gives us 1012. We have x squared natural log of x minus 1 minus, now guys, with 2024 now divided by 4, because this 1/2 multiplies here to give us 4. It simply gives us what? 506 x squared. Now then 1/2 times s simply gives us 1/2 x. Then the 2024 now multiplies 1/2 to give us what? To give us 1012 x. Then now the 1/2 here simply reduces it to what? To 10012 natural log of x minus 1. Guys, I'm sorry I didn't include the multiply here with the plus c. That's because I actually ran out of space, but I'll include it in the next slide. Great. So now I've simply factored out the natural log of x minus 1 from here and from here. So this is what I have here. Then now this is minus 506 x squared minus 1012x. Then now keep in mind, guys, that this 1/2 multiplied what? Multiplied the c to give us what? Minus c on 2. Then this 2024 now has to multiply this multiply this guy to give us, here is supposed to be minus, guys, here is supposed to be minus. So I'll just see if I can correct that. Here is supposed to be minus, guys, here is supposed to be minus, not plus. Yes, here is supposed to be minus, guys. I'm sorry for that. I'm sorry about that. Okay, now guys, here is supposed to be minus, so the 1/2 now is going to reduce this guy to be what? 1012c. Good. Now guys, keep in mind that this original integral was equal to what? Xy. So in this case now our xy now is equal to all of this, right? It's equal to all of this. So here is supposed to be plus. I'll simply just correct that now. Here is supposed to be plus, so I'll simply put back the plus here. Good. Because, oh my god, that's bad. I'm sorry, guys, that's bad. I'll simply just erase it. And we'll just correct that quickly. I'm so sorry guys for this mistake. I'm sorry. So in this case now, this is supposed to be what? A plus sign. Good. Awesome guys, awesome. So now this is exactly what we have now. Good. So guys, factoring out the negative sign simply gives factoring out negative 506 simply gives us x squared here plus 2x. Now since here was minus, it becomes what? Plus 2c. Good. Then now guys, if we divide now all through by x, since we have to solve for y, dividing all through by x, we are simply going to have our y to be, and also factoring out 506, we are going to have 506 on x into, we have 2x squared minus 1 times the natural log of x minus 1 minus into x squared plus 2x. Here is supposed to be plus again, so we'll just correct that. Here is supposed to be plus. Here is supposed to be plus. Then we have plus 2c. Great, awesome guys. So that's it. Awesome guys. Yes. So this is what we have, guys. This is what we have. So this is the value of. This is the answer to our problem. This is the answer. Okay. Here's the answer. So guys, thank you very much for watching, guys, and please don't forget to subscribe to our channel for more interesting content, because in this channel we are going to be uploading great content that you can't afford to miss. Okay, you can't afford to miss. So guys, thank you for watching the video, and see you in the next video immediately after this one. So guys, stay tuned, because we are going to be uploading great and interesting content that you cannot afford to miss. Thank you guys for watching the video once more, and see you in the next video. God bless you, and have a great day.